is add, subtract, you want to go big, we said. Once you get that bigger power, you are going to keep the same power of 10 as you do the problem, okay? The same power of 10. Whereas when we multiply, we add our exponents. So, Elena, when we divide on these last two questions, what did you do with your power of 10 when we're dividing? We are going to subtract the exponents. If we are subtracting those exponents, because we had 10 to the third minus 4, right, to give us 10 to the negative 1. And then you're dividing the coefficients, right? So you divide 7.3 divided by 1.2. And some of you are like, I don't know, I didn't write it down when I did it. I know. So today when we do the story problems, I'm going to have you write that down. I'm going to have you show your work as we are doing the problem. So please turn in your notes, if you would. So on this page, G11, we're on page 31. As you are looking at this, we need to choose the appropriate units as we are looking at these. We're going to have story problems. We're going to be comparing scientific notation. We're going to be doing addition, subtraction, multiplication, and division. And then we need to interpret it. Does this triangle look familiar to anything you've seen earlier this year in science?
Yeah.
Kind of. Like the what one?
The mass
Density, volume, right?
Yeah.
So many problems, math and science, can have these type of triangles. This one is used for distance. Okay, so d is our distance, equals speed, that's your rate, times time. When you think of this, we're going to find distance. So if I told you two pieces of information, a lot of times we measure distance maybe in kilometers, maybe in miles, maybe in meters. Yep, you could write this in your notes. A lot of times when we're thinking of speed. So if I'm thinking of how fast I was going and I say, you know what, I was on a drive and I was going 65 miles per hour, right? Miles per hour is how we a lot of times say our speed. And I was traveling for 4 hours. Can I figure out how many miles I ended up going? So if I'm going for 4 hours, I can actually multiply those two, right? So to find distance, we're always going to take speed times time. When I think of finding time, so when they say how many seconds, how many hours, how many minutes, if you're given the speed and distance, the formula asks to find time. We're going to look at our speed. So if I'm asked to find time, time would be like how many hours did you do that? How many minutes? How many seconds? That's when you do time. That is going to be a division problem. We're going to take our distance. Oh, we traveled 300 miles, right? And I was going 60 miles per hour. Going the speed limit. That's going to tell me how many hours it took me, right? So I'm taking 300 and divided by 60, miles divided by miles per hour. In the last one, if I want to find speed, I'm going to have to be given distance and time. So speed is here in our triangle, distance divided by time. Speed would be miles per hour. It might be kilometers per hour. So the key thing, and anytime you're looking at speed, a lot of times you're going to have that word per. So my distance, still going 300 miles. And this time it took me 10 hours. There was a blizzard, right? That 300 miles took me 10 hours to drive. I was going pretty slow, right? My miles per hour, I was only going 30 miles an hour on average if I was looking at that, right? So when we think about these different problems, we're going to read our problems, our stories here. So as you start us off, Abby, would you please start and read the story problem?
The speed of light is 3 times 10 to the 8 meters per second. If the sun is 1.5 times 10 to the 11 meters per second, how many seconds does it take for the sunlight to reach Earth?
So the most appropriate form. This is going to be key on the test. So what is most appropriate? Normally we write numbers in standard or decimal form. So like instead of 3 times 10 to the 8, we would have the 3 followed by the 8 zeros and the 1.10 zeros. But those get really ugly. So if it is too big of a number or too small, we're going to keep it in scientific notation. My hint would be, when you're trying to decide if it's appropriate, if you have something like times 10 to the negative 3, say you have 4.1 times 10 to the negative 3, it would be appropriate for you to say, oh, that is going to be 0, 0, 1, or 4, 1, right? Does that make sense? But that's a pretty small number. I can easily write that in standard form. If I have 4.1 times 10 to the, I would say anywhere from 5 to 7, I would be okay with you writing that in standard form because that's just simply telling us, with those 4 zeros behind there, that's like 410,000, right? If we are looking at that. So that's a pretty reasonable number for people to read. It's when they get into the millions and billions and trillions, and people just have a hard time. They're like, oh, how many should it be? So then keep it in scientific notation. So this one, we are asked to find what, as we read the question, Catherine. What was the question? Find what? How many seconds? How many seconds means we are finding time, right? So think of that distance triangle. Please draw the distance triangle. Distance equals speed, time. So if I'm going to set that up, I want to find time. I want my time to be in seconds. How do I find time? I take distance and I divide it by my speed. My distance was, which one of these numbers is my distance as I look at it, Fauna? The second one. So a lot of times people think, oh, it has to be the first one. No, it doesn't. Distance in this case was 1.5 times 10 to the 11th. The speed that we were traveling, that's where it says. The speed, 3 times 10 to the 8th. We said at the beginning when we are dividing, what are we going to be doing, Elena? Okay, when we divide, what do I do with these numbers with your calculator? I'm going to take, and this is where for some of you, I want you to show your work. I want you to put down 1.5 divided by 3. I know, I just saw that. So 1.5 divided by 3. And some of you might be thinking, oh, I know. 1.5 times what is 3? 2. So this has to be point, put it in your calculator, 0. What'd you get? 1.5 divided by 3? Yeah, I know. Or the test is that you actually put this down. Someone says, well, I know what I'm doing. I know, but some of you will make a mistake and put something like 0.2 or 2 when it should have been 0.5. Then we are going to write our 10 to a power. Bert, what did we say we're doing with our powers when we divide? Subtract. So I have 11 minus 8. I'm going to write that down also. Ashley, if I write that down, I'm going to have 10 to the 3rd. Now, this is not in scientific notation, but do we think we want our answer in scientific notation for how many seconds? This is a small power. It's less than 5, right? Change it to standard form. In standard form, what would it be looking like, Emily?
5 times 10 to the 4th.
Yes, but I want to write it in standard form. I don't want to write it in scientific notation. So how many places am I moving this decimal over to the left because of this number? 3 places. So when I move it over 3 places, I'm actually going to have a solution of 500. And I do agree with when you said that first answer, I think you said 5 times 10 to the 4th. It actually would have been 5 times 10 to the 2nd. This would be scientific notation, right? Because this is between 1 and 10. And since you moved it to the right, you have to subtract 1 from 3 and make it a 2, okay? But key thing, you must have the labels. When you answer these questions on the story problem of the test, I need to see this work and how you are setting it up. All right, so looking at the top of the next page, please read for us, if you would, Brian. Out loud, please. Okay. Sometimes when you think of these huge numbers, it's hard to think of how to solve the problem. So make it a simpler problem. If I'm thinking of this as a simpler problem and I say, you know what? A baby is born with 2, whatever it is, okay? And the adult is going to be 10 times as much as the baby. The adult cells of this same thing. The adult is going to be 10 times as many, right? So if that adult has 10 times as many, what would you do with those two numbers to find out how many cells or what they have? You would what? Add, subtract, multiply, or divide? Multiply. So people look at this problem and they go, oh, these huge numbers. I don't know if I should multiply. Do what you think. Read the problem and make sense of it first and then plug the numbers in. So we're going to write this in scientific notation. This is how many cells that newborn is born with. 2.6, Aiden, we're going to put times 10 to the what power? Okay, go 3, 6, 9, 10. We're going to leave the other one and we're going to say times the number of cells. The adults have 1.9 times 10 to the 3 number of cells. That just means that adults have, if we are looking at that, right, 1,900 times as many skin cells as a baby. That's what that means, right? So make sure you're writing this down. You with us?
Yeah.
Okay. So we are going to multiply. On your calculators, we are going to take 2.6 times 1.9. Elijah, you ready? 2.6 times 1.9. You got it? Tell me. How about?
4.94.
Thank you. 4.94. We're liking this because it's already in scientific notation, right? This is a number between 1 and 10. Times, I'm going to be doing what, Zach, with my exponents? Adding them. So 10 plus 3, I'm going to write it that way. Some of you in your notes, I'd like you to write it down, even if you don't like to show all this work when you do your homework. So Zach, I'd have 10 to the 13. Does this one make sense to write it in standard form for looking at how many cells? No, we don't want to have that many zeros. On the test, I do not want to have to count that you have 11 zeros instead of 10 zeros. So you want to keep this in scientific notation. So when you look at these questions, what you want to think about, if there's a ton of zeros either in front of the decimal or behind the decimal, you do not want to write it in standard form. You're going to leave it like this on the test. Turn to the next one as you take a look. And as you are reading that next one, Angel.
The population of North Dakota in 2012 was 6.99 times 10 to the 5th. The population of the town of Oak County that same year was 1.84 times 10 to the 5th. Well, how many times as great is the population of North Dakota as compared to the population of Oak County?
So we want to find how many times as great is North Dakota, the whole state, compared to Oaks. Okay? Times greater means we are always taking it and finding, doing what operation should be division. Someone said multiplication because it says times in it. No. We are trying to see how many times the state of North Dakota's population is bigger than Oaks' population. So we are going to write it as 6.99. Now 6.99 times 10 to the 5th, that's not that many, right? That's just 3 zeros behind this. It's like 600, like almost 700,000, right? This is an estimate, keep in mind. Divided by Oaks population. What is Oaks population in standard form? Oaks population in standard form would actually be 1,000 what? 840 people. Isn't that what it looks like in standard form when we think about that? So when we are looking at those, we want to write it that way. And now we want to divide by 1.84. So in your calculator, as I am looking at that, Mia, what would you be putting in for my numbers to show the division?
6.99 divided by 1.4.
Okay. What'd you get?
I got 3.79.
Say it one more time.
3.79.
3.79. Nice, it's in standard notation. Betsy, what are we doing with our exponents when we divide? Subtract, so I got 5 minus 3. Now, Angel, if you, or Mia, if you go back, this was 3.79 what? Okay, so if we are gonna round this, do we think we wanna go to 3.79 or 3.8? 3.8. So when you look at those numbers behind your decimal point, it's really important that you don't just stop and go stopping at 2 decimal points, but this is really 3.8 times 10 to the second. This is a small number. This one should be in standard form. Appropriate form on the test. I don't want this in scientific notation, right? How do I want you to leave your answer for this one? I want this answer to tell me that it was 300. North Dakota's population is 380. So you're going to write it like this on the test because vocabulary and writing down your answer is important. 380 times greater or 380 times more. I would take greater than if you were looking at that than the state of North Dakota instead of higher than. You wanted to use greater, okay? All right. We've got 2 more on the next pages, and I'm going to save the other 2. Dylan, go ahead and read for me, if you would, please, on that next question.
1 light year is equal to 9.5 times 10 to the 12 kilometers. The Andromeda galaxy is about 2,003 light years away from the Earth. How far is that in kilometers?
Okay, so this is kind of an ugly problem here. Again, I want you to think of this. They're telling you that 1 light year is a certain number. This is how long it is. That's kind of like me saying 1 mile in the city is 13 blocks. Okay, if you knew that, 1 mile is 13 blocks. And I said, you know, we have to walk up to the park way up north, and it's 3 miles. And I said, how many blocks do you think we're going to walk? What would you do to find out how many blocks? You would multiply 13, right, times 3 to get that answer. This one is saying 1 light year is this. And the galaxy is this many light years. That's like saying 3 miles. It's saying like 1 mile equals this. This is this many light years away. So what are we doing with our problem? This is a multiplication. So if you can think of it as a simpler problem, right? We are going to take 9.5 times 10 to the 12. We're going to write that 2 million times 2,300,000. Emily, in scientific notation would be times 10 to the which power? 6. So now, as I begin, Katie, to multiply 9.5 times 2.3. Again, someone said, do I have to write that down? I'm doing it in my calculator. Well, if you make a silly mistake and add those instead of multiplying them, and then I have to mark it wrong on the test. So, Katie, what'd you get? 21.8. Then I'm going to have 100 times 10. What are we doing with our exponents when we multiply? Adding them. So I'm going to have 12 plus 6, which gives us 10 to the what power? 18. Okay. This is not in scientific notation, right? 21.8 has to be a number between 1 and 10. What should I be looking at for the first number? And this is where you want to keep in mind that bars, right? Left, add, right, subtract. Left, add, right, subtract. We're going to rewrite this instead of 21.8 as 2.18. This is a number between 1 and 10, which has to be the case, right? I moved it to the left. Since I moved it to the left one place, to 18, I'm now going to make it 19. I am adding. Left, add, right, subtract, okay? So, as you are looking at that, we're going to do this last one with the grasshoppers. Haley, you want to do me a favor and read? Will you anyway? It's not bad. You are going to have a density question on the test. It might not be the density of grasshoppers in an acre of land, but you will have a density problem. First off, what does 2.4 times 10 to the 6th look like? If I asked you on the test to just write it in standard form, that would be what? How many zeros?
5.
5 zeros, right? 1, 2, 3. So it's like 2 million. Oof, 400,000 grasshoppers, right? That's a lot. And in 3 acres, when they say density, they want to know how many grasshoppers, okay? What they're trying to find out is how many grasshoppers per, so this is our per, this is the 1, okay? Per 1 acre. Well, we knew there were 3 acres, right? That's how our problem started. We had 3 acres of land, and we have 2.4 times 10 to the 6th. And the question comes up when we're taking the test, hey, do I always have to do everything in scientific notation? No. So if we are looking at this, we should have had with our 5 zeros behind that. Could you think of this as taking 24 divided by 3? 24 divided by 3, most of you know that, right?
Yeah.
24 divided by 3 is?
8.
8, but in this case, we'd have to have 0.8, right? Times 10 to the 6th. What if someone did this division, 2,000, 400,000, and they divided it by 3? Is it going to give me the same answer? Please do that division. Please take 2,400,000 and divide it by 3. You have your calculator, so it shouldn't be hard. We are looking at how much? Put it in your calculator.
5 zeros after.
So we're talking about, how would we say that number?
800,000.
800,000. Oh, this was 0.8 times 10 to the 6th. Someone said if I was going to write it in standard scientific notation, it would have been 8 times 10 to the 5th. I agree. I would have taken this answer. But when I'm talking about grasshoppers, doesn't it make sense to tell me when it's like less than 1 million or 100 million? To say there are 800,000 grasshoppers in that 1 acre, by the way, if we're thinking about an acre, does anyone know how much an acre is? If you think of like maybe like 5 city blocks by 5 city blocks, that's a lot, right? So anyways, we are looking at that. Tomorrow, we're going to look at problem 6 and 7. I would like you right now to turn to your G11 workbook. We're going to kind of start this out and do a couple of problems together.